Hello people, so let's solve today's LeetCode daily question, that is 931 minimum falling path sum, and in this we'll be given an into n array of integers matrix, and we have to return the minimum sum of any falling path through matrix. Okay, and a falling path starts at any element in the first row and chooses the element in the next row that is either directly below or diagonally left or right, specifically the next from the position row comma column, where the next element which we can choose will be at the index row plus 1 or and column minus 1, or simply just the next row in the same column, or next row or even the same column. That means if we are standing at, let's say, 1, we can either go to 5, we can either go to 6, and can either go to 4. And by choosing the path from the first row, we have to determine that it will be the minimum cost to reach the bottom. Okay, so let's say if we start from 2, then we have options for choosing like 6, or we can choose 5, and from 5 we can either go 7, 8 and 9. From the very first row we have to traverse, and we have to return the minimum falling path sum from the zeroth row. Okay, so there are two ways for doing this. You can either start from the very bottom using the DP array. You can store this particular column, and then you can calculate by going up in the three directions, and from where you will get the minimum path sum. Or you can just start from the topmost index, and then you can keep the track of the minimum path sum. Both of the options are valid. I'll be showing that we'll be starting from the zeroth row and we'll be moving down the line. Okay, so let's first have n. We are given that it is a n cross n matrix, so we don't have to worry about the m here. Okay, so matrix okay, matrix dot length will also work. Okay, so now let's have a DP array. Okay, let's first check that if n is equal to 1, this is the base case. That means the size of matrix is 1 cross 1, then we have to return matrix 0 0. Okay, so now let's have a DP array where we'll be storing all the possible sums that we'll be calculating is equal to new int of n cross n. Okay, and let's just okay, let's for int row in the DP array. Let's fill it with the maximum possible value, as we have to return the minimum value, so we have to return fill the array with the maximum possible value. So arrays dot fill. Okay, let me just zoom in to it. The arrays dot fill row comma integer dot maximum underscore, okay, dot max underscore value. Okay, so now let's start traversing the every column of the ith zeroth row. Okay, so let's have variable for int column equal to 0 and columns less than n, column plus plus. And just notice that in the every iteration will be starting in the zeroth row only, but in different columns. Okay, so let's say we are firstly starting from the this column, the column where 2 is present, then from the next time we'll be starting from 1, then from 3. Okay, so let's also maintain an answer variable is equal to let's say maximum value, integer dot max underscore value, and we'll be updating the answer as is equal to math dot minimum of answer, and let's call the function that will return as the falling path sum. Let's call it falling path sum, and it will take parameters as the obviously the array matrix, the starting row that will be always 0, and the starting column that we are passing over here, and the DP array. Okay, so and at the end what we have to do, we have to just simply return the answer. Okay, so okay, so now let's write the recursive function that is the minimum path sum. Let's call it private, and it will be of a return type int falling path sum. Okay, and it's taking parameters as a matrix and row and row and the column and the DP array. Okay, and DP. And now let's first check that uh, and okay, let's pass n also because otherwise we'll have to calculate that again and again, comma and n. Okay, so we'll be checking that if we are on the last row, that is if our row is equal to n minus 1, that means we are on the last row. Then what we have to do, we have to return dp of row column, that will be equal to matrix row column. Okay, row column, that means we'll be just storing the results, and then we'll be checking that of dp of row column is not equal to the maximum value. That means we have already calculated that result, max value. Then what we have to do, we have to return dp of that particular row and column. Okay, so now let's have set three ways that we can either go. We are having three ways basically. We can either go here, we can either go into the left diagonal, or we can go into the right diagonal. Okay, so let's have variables left diagonal, that will be equal to maximum value, max underscore value. And similarly we'll be having for right diagonal, okay, that will be also equal to maximum value, because there are chances that we'll not be able to calculate, like let's say if we are at 2, we cannot go to a column minus 1 index because that's inaccessible, so we'll be returning minus 1 maximum value in that case. Okay, so let's say that we'll be calculating in this only that if my column is greater than 0, then what I'll be doing, I'll be setting that my left diagonal value will be equal to the I'll call the falling path sum function again, falling path sum, that will take parameters as matrix and matrix, my row minus 1, okay, sorry, row plus 1, my column, as we are going to backwards, so our column will be minus 1, and the dp array and n. Okay, and here I'll be checking that if I can go below, let's have a variable below, and it's all possible in all cases, so we don't have to check a particular case that if my row is less than this or greater than this, or if my column is less than this or greater than this, then we can just go down, let's say call the function falling path, okay, path sum, and let's have the variable matrix, and then this row plus 1, and column will be the same, so no worries, and the dp array and the n. Okay, now I have to check that if my column is less than n minus 1, that is I am not present at the last column, because if I am present at this column, let's say 3, so I can't go to row plus 1 and column plus 1, that's inaccessible for me. But if that's accessible, so I have to update the value of right diagonal as right diagonal, that will be equal to falling path sum, and it will be taking parameters as matrix, row plus 1 and column plus 1, and the dp array and the value of n. Okay, and at the end what I have to do, I have to store these in the dp array, so return dp row column, and I have to return the minimum of all these paths, so math dot min, let's say left diagonal, and I'll be calling the minimum function again, math dot min, and below, and the right diagonal, Okay, so this is how we'll be going through the question, and now let's run it. Okay, it gives me a wrong answer. Okay, its expected answer is 13. Okay, so I have to add the current also no matrix row column because I have to add the index which I am currently present also. Yeah, and it works perfectly fine. Okay, so now let's submit it, and works perfectly fine. Okay, so this was it for today. Thank you for watching.